Hi everyone, the question is, suppose the quadratic polynomial p of x is equal to ax square plus bx plus c, and since they are talking about quadratic polynomial, that means a is not 0. In fact, they have written ahead that has positive coefficients a, b, c. So a is anyway positive. And a, b, c are in arithmetic progression in that order. If p of x equal to 0 has integer roots alpha and beta, then alpha plus alpha beta equals. So here p of x equal to 0 has integer roots. So ax square plus a plus dx plus a plus 2d equal to 0 has integer roots alpha and beta. So here you may say, if I divide this whole equation by a, because a is anyway positive, so and that means a is non-zero, so that means x square plus a plus t, 1 plus t, 1 plus t x plus 1 plus 2t equal to 0 has alpha and beta roots, and here alpha and beta are integers. So alpha plus beta will also be an integer, which is minus times 1 plus t would be an integer. That means t is an integer, where t is essentially, as you might have already guessed, is d by a. So here t is d by a, common difference divided by the first term of this AP, ABC. So here now what about the roots? X will be minus 1 plus t plus minus root d by 2a, so to speak. That means 2 times 1. Now here since x is integer, it is also rational. That means d should be perfect square. D, the discriminant, is what? It is essentially 1 plus t whole square minus 4 times 1 plus 2t, and this should be a perfect square, let's say k square. So here what you have is, you have t square plus 2t minus 8t is minus 6t. 1 minus 4 is minus 3 equal to k square. That means what? That means t minus 3 whole square plus 9, so we'll do minus 9. So minus k square equal to 12 is what you are getting. Now mind it, since t is an integer, even t minus 3 would be an integer. So here without loss of generality, let me say k is positive. Yeah, because I'm saying t square minus 6t minus 3 should be a perfect square. Let's say k square. Let's say k is positive without loss of generality, or let me say k greater than equal to 0. Yeah. So here you get t minus 3 plus k times t minus 3 minus k is equal to 12, and of course d is supposed to be a perfect square of some integer, and since we have taken k greater than equal to 0, so d is k square. So we have taken k to be without loss of generality greater than equal to 0. Now this k square is 1, so it is 1 plus t is an integer, its square would be an integer, and 1 plus 2t would also be an integer. So overall left hand side is an integer, so k is supposed to be an integer too, and we have taken it to be non-negative integer without loss of generality. So here you may say it can be 12 1. Of course since k is non-negative, t minus 3 plus k would obviously be greater than t minus 3 minus k, so it can be 12 1, it can be 6 2, it can be 4 3. Now if you see carefully, in this case t minus 3 turns out to be what? 13 by 2, which is not allowed. Check it out. And here t turns out to be 7 by 2, which is also not allowed. T minus 3, by the way. Why? Because t minus 3 is supposed to be an integer. Now similar would be the fate if you consider the factors to be in this case, in this equation, minus 3 minus 4 minus 1 minus 12. T minus 3 would turn out to be minus 7 by 2 minus 13 by 2 in those cases also. So another possibility is, since t minus 3 plus k is supposed to be more, given that we have taken k greater than equal to 0, so t minus 3 minus k would be less than or less than equal to t minus 3 plus k. So here I'll take minus 2 minus 6. Yeah. So in this case you get what? In this case you get t minus 3 to be 4. That means t is supposed to be 7. Check it out. Yeah. And in this case you get t minus 3 to be minus 4. That means t is minus 1. Yeah. Now here you may say what would k turn out to be if t is 7. or rather if t minus 3 is 4, k is supposed to be 2. Check it out. Yeah. So here k is supposed to be 2, and here if t minus 3 is minus 1, my bad, if t minus 3 is minus 2, my real bad, I mean if t minus 3 is you get minus 4, so k again turns out to be 2 in this case also. Yeah. So what about the roots in this case? The roots alpha and beta you get as what, you put t to be 7, so you get minus 8 plus minus 2 by 2, so you have minus 4 plus 1 minus 4 minus 1, so you have minus 3 and minus 5. Yeah. And similarly here you get roots to be, you put k to be 2 and t to be minus 1, so you get essentially what, plus minus 1. Now here you may say that if roots are plus minus 1, that essentially means what? That essentially means that a plus b plus c, 1 being a root, is 0, and a minus b plus c is also 0. That means what? That means b is 0. But this is a contradiction. Why? Because it has been given that a, b, c are all positive. A, b, c are all positive. Why? Because positive coefficients they are. Yeah. So that means roots are supposed to be minus 3 and minus 5. Yeah. In which case we may take a to be, let's say 1, then b turns out to be 8, and c turns out to be 15. So they are in AP. Yeah. Similarly, you can take a to be, if you take it as some positive integer, some natural number n, then b turns out to be 8n, and c turns out to be 15n. So that means yes, a, b, c are being positive, and they are in AP. So minus 3 and minus 5 are the roots. So what about alpha plus alpha beta? It is minus 8 plus 15, which is essentially, or you may say it is minus b plus c. Doesn't matter here. My bad. Alpha plus alpha beta, you may say minus b by a plus c by a. Anyway, we have got the roots minus 3 and minus 5. You put it here, you get minus 8 plus 15. 7 is the answer. C is the answer. Thanks for listening.